All right, so let's take a look at domain methods, right? And by domain methods, we mean by domain we mean what is it that we're solving? What is the particular problem that we're dealing with? In this case, it's domains. I'm sorry, duration, right? And time. That is the domain that we're talking about. If this were I don't know, iTunes, right? The domains might be songs, right? Or movies, or whatever it is. Yes. And it would have its own classes and interfaces that deal with songs and artists and movies and playlists and whatnot, right? And so that would be all the classes and all the methods that would go along with playlist, add song to playlist, right? Or add artist or whatever, right? So those methods are specific to that domain. Make sense? Right? For us, the domain methods that we might have is that we're comparing durations, we're adding durations, right? Those are the domain methods for a specific domain problem. So for instance, in the first domain method that we're going to look at is in seconds, right? We want to be able to convert whatever representation you have. In this particular case, our representation is hours, minutes, and seconds. We want to convert that into just seconds. What is the canonical representation? So we do the math here. Multiply hours times 3600, multiply minutes times 60, and then add the seconds, and that converts. My particular implementation converts it into the canonical seconds. Yes. If there was this some other implementation that uses the lunar calendar or the Gregorian calendar or some other implementation, it'll be, it's so many moons and so many whatever, right? It tells me how many seconds that is. And it'll be some other implementation from some other class. Yes?
Is the override required?
Yes, it's a good practice. The compiler will complain and let you know. Yeah, it depends on your settings on how rigorous the implementation is. Yes? Okay. Yeah, no. So in object orientation, override is somebody above you, some higher class, some base class or interface, right? Declared some particular signature, right? And you happen to be declaring a method that has identical signature to whoever you're inheriting from, right? In this case, we're implementing the duration interface, right? And it declares this method that has the identical signature, right? And this could be interpreted in two ways, right? It could be interpreted: are you overwriting, right, or are you overloading, right? And oftentimes you might need to be specific on what it is that you're doing, right? Overloading is that I am providing a new version of the same method, right? It has the same identical name, has the same return type. But the signature might be different, right? The arguments that you're passing are different, right? One of them accepts integers, whereas the other one accepts strings. Yes. So you would tag it as overloading, right? Overloading, saying that, hey, this is just a different version of the same methods, right? And depending on the arguments that you pass, I'll call one or the other. Here is a strictly override, meaning whatever implementation you might have, which we don't have one, whatever implementation you might have. Forget about it. This is the implementation that I want, right? So this child class is overriding their parent, like many children override their parents. Yes.
What I was thinking about that is with delegation. Aren't you already doing that if you're delegating to that specific subclass?
Yes. Here we're just going a little bit more formal, right? And tagging it as an override. And you're telling the compiler, check for this, validate that this is true. And for instance, if I change the signature here, right, it'll say nope, it's not an override, and the compiler will complain. It says, well, no, it's supposed to be an override, and I don't see any signature that your parent implements with that signature, right? So this is not truly an override, right? So it's a good practice to tag it so that the compiler will let you know, hey, no, it's not really an override, right? Or an overload and whatnot. Okay. Yeah, we are asking the compiler, right, to look for these things for us, right, and let us know if we inadvertently, right, change the signature somehow, and it will let us know at compile time as opposed to at runtime, right? We want to make it as early as possible, catch problems as early as possible, right, at compile time. Yes.
This is in the duration input class?
Yes, yep, we're implementing, right, yes. Where was I? Right, so this is the first function that we are implementing. And then also we're going to implement, and we're going to override the conversion that's going to format this duration in some friendly way to consume it in a friendly way, right? That we know that we use colons, we use hours, minutes, and seconds, and we use colons in between. We also like to our frontal cortex likes to see paddings and things that align and add the zeros before the numbers so that they're all nicely aligned together. So we're using some formatting strings, Java formatting strings, that the format function takes as argument a string, and then with formatting characters in there like the percent and the Ds. And then it can take any number of arguments, integers, floats, strings, and whatnot, and they're fed into the format string. Here we're saying that we want a digit, a number. Here we're saying that to pad these numbers, give at least two character width, right? And if it's not big enough, to pad it with zeros in front of it, right? So this is a set of characters that are used by the format function to format your string. What I just said. So the %d allows you to format integers, the Ds, and then it pads. The default padding is spaces if you don't specify, but if you put a 0 in front of the character, then it will pad it with zeros, right, to fill in any gaps, any missing spaces. All right, so the other operation that we're interested in implementing, which is part of the model, is the plus operator, right? We want to be able to take two durations, add the current duration, the current instance that we're in, add it to an instance that is going to be passed as a reference, right? And then return a new instance that represents the addition, the arithmetic addition of both durations. So the easiest thing, the strategy might be to represent them both in the canonical representation, both into integers, right? And then once you have them all in integers, that's easy, right? You just add them up, and then reinstantiate the new duration in whatever format is being asked for, right? Whether it's a duration impl, or we'll see later on a new implementation. Now, because the fact that we want to be able to reinstantiate a new version of duration that contains the new data, right? The new version of the addition of these two, right? We might start looking for a more convenient way to instantiate these things, because I'm going to have a seconds, right? I'm going to add duration 1 plus duration 2, and what I'm going to end up with is seconds. Yes? So I would have to kind of do the conversion backwards, right? Because I would have to, the representation that I have currently is hours, minutes, and seconds. Yes? But I only have seconds, right? So I would need to somehow here do the conversion backwards from I already have the conversion from hours, minutes, and seconds down to seconds. That's in the constructor, right? And the in seconds. But I would need some way to convert it back, right? To go from seconds back to hours, minutes, and seconds, right? And that would be very inconvenient. And again, instead of doing the conversion everywhere, in this particular case, we would need to do it here, right? But this probably wouldn't be the only place where we have to convert backwards, right, from seconds back to hours, minutes, and seconds. There will be many places in our code that might need to do this conversion. Yes, to go from one representation to the other. So what we are going to do is that we're going to encapsulate the fact that we need to be able to convert backwards, right? We're going to capture that in a second constructor, right? in a second constructor that does not take hour, minutes, and seconds, instead takes seconds. That's all we have, right? Having added the two durations. So this is again, this is kind of an example of syntactic sugar, where we provide different versions. We overload, right? We overload different methods, different constructors, to make it convenient for us, right, to instantiate or use them depending on what it is that we currently have. Right now we have seconds. Well, it would be very convenient to have a constructor that takes seconds, right, instead of just hours, minutes, and seconds. So let's do that. We'll create a second constructor that will make it easy to do the conversion backwards. Once we have once we have the constructor, and now we already have in seconds, it'll be very trivial, right, to just implement the plus operation in terms of these decisions. So here it is. Here's the constructor. Here's the second constructor, our syntactic sugar constructor, that instead of taking hours, minutes, and seconds, this takes seconds, right? And instead of doing the conversion from hours, minutes, and seconds down to seconds, this goes backwards, right? This takes these seconds, again, checking to see that seconds is not negative, and does the conversion backwards into seconds, minutes, and hours, right? Centralizing the conversion between these two representations, right? From the canonical representation, right, into the more convenient hours, minutes, and seconds. Make sense? Right? Once we have this, that's easy. Yes?
So in the previous method where you return the number of seconds, it automatically cast it to a long, but you have to explicitly cast a long back to an int?
Yes, because they're not the same range, right? An int, a long can fit much bigger numbers, right? And you have to deal also with if there's an overflow, right? The flow that the long might not fit into the integer. But we're okay. We have we have small values, 60, 60, and yes, you would have to deal with potential overflows on really large seconds, right? And you have to split it up and do some additional validation there. Yes. So you got to be careful with if the seconds is so huge that's not going to fit into your integer. Yep. So integer in this case is it's a casting, and you have to be careful, right? That long might be too big and not fit into the integer even after dividing by 3600, right? That you would have to deal with that, right? Right. All right. So once we have this new constructor that takes just plain old integers, right, or long, the implementation of the plus operator is trivial, right? We just need to convert both versions, right? The current implementation, the current instance that I'm in, convert the other instance back to seconds. So when we have that, we just add them up just using plain old arithmetic, and then we can instantiate a new duration impl, which is also immutable, right? So notice that we're not changing anything. We're not changing my current instance, right? We're reinstantiating a brand new version of the value. Okay. So let's take a look at some of the standard methods, which are not necessarily the domain methods.